Here's integrated 3. It's problem number 12-24. It says Jeremy uses the inverse sine button on his calculator to solve a trig equation and gets 37 degrees. He knows that there must be more than one solution. What are the rest of the solutions to Jeremy's equation? Use a unit circle to explain how you determined all the solutions. So let's find 37 degrees on our unit circle. Well, we don't have exactly 37, but there's 30 and there's 45. So 37 degrees will be somewhere in here. And remember, we were using sine, not cosine. Sine is the y values. Sine gives the height because it's opposite over hypotenuse. Okay, so sine of 37 would be up here somewhere. And it would be positive because it's the y value. So where else could we get a sine of 37? Well, if you're saying maybe over here somewhere, there's going to be this symmetry. It's going to be right here, and then there's going to be another one right here because I don't know if you guys remember the screamer ride. Okay, let me draw it. I don't want to draw in my unit circle. When you first learned about sine and cosine, they told you this thing about the screamer ride. It was some kind of roller coaster, and sine is opposite over hypotenuse, and we were using sine, like the hypotenuse was, I think on the screamer ride it was 100, but we were using a model where this hypotenuse was just 1, and then we were getting, this is opposite of the angle, right? If this is 37, this is the height above the x-axis. That's what sine gives you. That's why we have x comma y. It's the y value. It's the height. Okay? So there's going to be another one with the same height, like this and this are going to be equal height. So there's going to be another value over here. But how can I get the degree measure for that? Well, I guess I could go, if I went all the way, like that's 90 degrees and that's 180 degrees. And then if I backed up by 37, what's 180 minus 37 anyway? Let's see. $143 degrees. So this, even though right in here this would be 37, the angle measure is 143. So I got 143 degrees and I got 37 degrees. And I can keep, now if I went down here and made the same triangle, sine would be negative. Same with this. So we don't want to include those. But we know that we could go around the circle by 360 degrees and keep landing here over and over. So we're going to add a 2. Oh, no, we're not going to say 2 pi n. We're going to say plus 100. Here we're going to say 37 plus 360 n, I guess is a good way to say it. And then we'll say 143 . So that's how I can say all of the different position, or all of the different solutions to inverse cosine or inverse sine of 30, or the sine of 37 degrees.